So I think we've got a really good skill set to go after these already. What I'm interested to know first, let's take a little poll. I'd like to know how you tested your points. So it's been all over the place. Raise your hand if you substituted your x, y coordinates into the inequalities and saw if it worked. Anybody do that? Okay. So first hour was like 50-50. Second hour didn't have very many that did that. This hour is almost 50-50. Who plotted the points on the graph and just saw if they're in the double shaded area? Okay. So I think that's less work. I'm not afraid of work, but I just think that works really well here. So that's both ways do work. So I'm going to go test out 3, -5, which would be right there. And how many of the constraints does that satisfy? Only one. Okay, so that's out. 0, 5 is right here. How many restraints does that satisfy? Both, okay. -6, 6. How many does that satisfy?
2.
Both. It's right on the line, guys.
And it's a solid line.
Okay, it's solid. Okay, 3, 3. Oh yeah, it's on the line.
3, 3.
Oh, the line's dashed. Here's how you know it doesn't work. 3 is not less than 3, right? Okay, so that's what the dash line means. So that doesn't work. -2, -2. Oh, it's right on both lines.
Nope.
However, it's on the dash line, so it fails this one, right? Cool. So, all the solutions can be on this solid line except that point right here. Can't be there. And then everywhere shaded, right? Cool. If you had to redo it, who would use substitution?
I did.
It's okay if you still want to do substitution. You can't, okay? If you redid it, who would probably just graph it? Yeah, they both work, but you can still substitute. In fact, when it landed on the line and you're unsure, substitute it and see if it's true or not, right? Eyes on the board, mouths closed. Some information I'm looking for to see if I can have this team of, let's do X children and Y adults. Okay? Let me ask you some questions, okay? How many people can be on this team?
16.
16. So I've got this inequality. X plus Y needs to be less than or equal to 16. Is there any minimum?
No.
Okay, so I could have 16 children in theory. There's 16 people on the team. 16 people on the team. So this constraint for kids on the team, or people on the team, is all these. But I'm thinking maybe, can I have adults only?
No.
Can I have children only?
Yes.
Okay, so there must be something about adults and children. What's the requirement for adults on a team?
The number of adults must be at most half the number.
Adults are at most half the number of kids? Okay, so adults need to be less than or equal to half of the number of children. Is that what you're telling me?
Yeah.
So this is up 1 over 2, up 1 over 2, up 1 over 2. This is going to make me a nice straight line. The line works though. You can have half. So then under this line, so I'm looking at this area right here for the solution set, right? Okay. So then the two questions on the card were, can you have 8 children and 6 adults?
No.
Well, let's go test it out. 8, 6 is right there. Does that work?
No, because it's not.
It's only 14 people. I can have 16.
Too many adults.
Oh, stinking adults. So if I had 8 children, how many adults could I have?
4.
4, okay. Or if I had 6 adults, how many children could I have? 12, but that'd put me over.
Yeah.
So what's the highest number of adults I can actually have?
5.
Are you guys seeing that spot right there? That'd be the spot, right? How many adults is that?
5.
5 adults.
And
11 kids.
Why not 5.5 adults, guys?
Yeah.
No, you can't have a half adult. Maybe a really immature 18-year-old and you just count them as half. No, I don't know. But 5. So we answered the two questions. Does this work? 8 kids, 6 adults?
Mr. Matt.
What about 5 adults, 11 kids? That'd be the most adults we could have right here, that red spot. Okay.
Mr. Matt.
So 5 adults is the most. I've got some questions. My first question is, how many people can be on this team? Who can raise their hand and tell me how many? I want to know how many people can be. Vinny? So children and people, or children and adults, need to be 20 or less, which gives me this line right here, and anything less also works. Okay, that's good. That's good. That's good. Can my team be all children? Ooh. Okay. Can it be all adults? Can my team? How many adults need to be on my team then?
At least 3 kids per adult.
3 kids per adult. So I could say that the number of adults needs to be less than or equal to 1/3 of the children. The number of the children. So that'd be this line here. A y-intercept is 0 and a slope of 3. Okay, okay. So similar to the last one, but different. All right. And that would put the solution of that under that. All right. Now, do I have to have any adults on the team this time? Oh, snap. How many? What's the requirement for adults?
1 adult per 3 kids. That's no point.
So I can have 1 adult and it satisfies it? I could have a team with 1 adult and 3 kids?
Yes, you actually could.
Anybody want to disagree with that?
No, minimum.
Who can tell me what that last data point is on the data card?
No, he can't. He can't.
So that bottom one says, what about the number of adults on a team? What is that? So I have to have 2 adults, exactly 2 adults?
Yep.
Or anything over.
Oh, 2 or more adults. So I need y to be greater than or equal to 2. That means each team needs at least 2, so I'd shade up here. That's that last data point, guys. So that means, oh, I need a smaller highlighter, son. That means anything up in here is my answer. So what were the questions again for this one that I need to answer? The question was, what was the highest number of adults? Is that right? It's this spot right here. So if I had 15 kids and 5 adults, does that work? Shh. Hey guys, we're trying to put it together here. If I had 15 kids and 5 adults, does that work?
Yes.
So the most adults I could have is 5. What was the next question? What's the smallest number of children?
It could be 3. No, it would have to be 6.
It should be 6 because you
Well,
have
let's
to
look.
have 2 adults.
Yes.
Where's the smallest number of children? Right there.
You have to have 2.
So the only thing that meets all those constraints would be 0.62, which means 2 adults, because you have to have at least 2 adults. You have to have 3 times as many children. So 6 would be the smallest number of children, which also means 8 would be your smallest team possible, right? Cool. So how many constraints were there on this one? 3. This one would be up in there too, right? That's pretty cool. Friends, that's it for today. That's all we got. That's all we got.